Hi, today I'll show you how to run OpenWRT in QEMU on macOS, an M1 machine. So, stable versions of OpenWRT have ARM-SR, ARM-v8, a combined EFI machine image. All the versions, like 2305, still have a combined image and the ARM-SR, ARM-v8 as well, but it is not EFI. Even older images, such as 2203, have ARM-vert 64, but do not have the combined image. Let's start with 2410, and then I'll show you 2203, noting that the procedure for 24 and 23 is the exact same. Because of this new version, you can simply download the EFI image directly. So note that you do need to use gzip on this image. Now, create a machine in UTM, which is the tool we'll be using. Virtualize Linux. Boot image is supposed to be this combined image. Continue. You can configure however you want, but the important part is the VM settings. Now, I disable the display. Instead, I add a serial console. Additionally, personally, I like to change this because as it stands, it is not correct. So I delete my virtual drive. I delete the USB as well again. I replace it with a raw image, virtual, non-removable, so that now our disk is a non-removable image, the raw image. It's a bit bigger. You can make it smaller by using QEMU image to convert it between formats. So you can do QCOW2 if you wish to, but that's not part of this. So save and start. There we go. It will take a bit to start the bootloader. Need to wait for it to show press enter for. Here we go. Press enter to activate this console. You press enter, and we have a shell. Now, you do need to configure the networking. So that is an etc config network, and by default, it will create a bridge device. I recommend you change your configuration from static to DHCP. This should be sufficient. Do note that OpenWRT does have firewall configuration. With the configuration changed, we start the network, which will disable and re-enable it, at which point you should have an IP address, and you should have internet connectivity. That was it for 2410. Now, 22, which is a bit more complicated. You have images, you have init-ramfs, and you have rootfs. Default rootfs is just files, which is useful if you need to do a Docker image, because this is the rootfs. But what we need is a file system. So you can select ext4, squashfs, CPIO, it doesn't matter. I'll use the ext4. Sorry. There we go. I'll delete the old one and replace it with the new one. Once again, this image is gzip, so we need to decompress it. Once decompressed, we go back into UTM. We create our virtual machine, but this time we boot from a kernel image. The Linux kernel is the one we also need to download, sorry. Init-ramfs is not technically necessary, so the kernel should be sufficient. We do specify the image, which does not need to be decompressed, and the rootfs image can also be provided here. Continue. Once again, disable the display, because we do not need VGA, but we need a serial console. Now, you'll see one problem that shows up when you do this kind of more instantaneous, more configuration with the kernel. When it boots up, it will panic. Now, this might seem like a problem, but it is not. I'll make the terminal slightly bigger, and you'll see the images here, VDA and VDB. One of the things you can say is simply to boot up from this, because we're running directly with the kernel. So you must configure your arguments, especially. You add a new field. If I remember correctly, I believe this is VDA that we want. I am not sure. Because I believe it still adds a big image. Yes, we don't want the QCOW image. But we do want our image here. And this should be VDA. So I believe I forgot to save it. There we go, this boots up. And once again, press enter to activate this console. And now we have OpenWRT running 2203. So that's the older version. We didn't have a combined EFI image. Once again, for networking, you need to change from static to DHCP. And you restart the service. We now have an IP address and internet connectivity. Note that you can convert these images however you will, however you wish. Once again, you do have access to QEMU image if you install QEMU. On macOS, you can use root to do so. This will allow you to convert between formats. Note that if you do convert to a QCOW, you will still need to resize everything because the predefined sizes are quite small. So yeah, you now have OpenWRT running in UTM. Note that this is also applicable to Proxmox, and this is UTM is simply a wrapper around QEMU. So all I've shown you is the high-level ideas, which is using how to use a serial console. That you need to disable the display, use a serial console instead, and what to use and how to use it, which is specifying a Linux kernel, specifying a disk image, and that's about it. And also how to append the rootfs, because this append command is simply a QEMU argument. Now, the things listed here are extreme, and in reality, you don't need to go this insane. After all, UTM also adds sound, which we do not need. But yeah, hopefully this allows you to run OpenWRT on M1 for all your development and testing purposes.